box with a square base and an open top must have a volume of 2,916 inches cubed. Find the dimensions of the box that will maximize the amount of material required to make the box. Okay, so what we should do here first is sketch out a picture of a box. Oop. Easy way to do this is to make two rectangles that kind of overlap like so, and then just connect all your corners. All right, so from here, it has a square base. So I'm gonna say this is X and this is X, just so I know that they're both the same side, right? But then we can change up the height, right? So the things that are going to change here on my box are going to be the size of X or the size of H, right? And then what we want to do is we want to change them in such a way that the volume stays exactly 2,916 inches cubed, but the surface area is as big as possible. So, actually as small as possible. That minimizes the amount of material, which makes sense, right? That's probably what you'd want to do if you were packaging this. Okay, so what we want to do is we want to write down our equation. So a good place might be, I want to minimize the material, right? So I want to minimize my surface area. So let's do this. I'm going to write it over on the side here because I'm going to leave space in the middle. But so we want to say, okay, the area. And let's make ourselves a little equation for the area. So the area would be, well, x squared, right? Because it'd be x times x. That would just be the area of the bottom of the box. And it has an open top, so I don't need to multiply that by 2. So this accounts for the bottom of the box, and I don't have a top of the box. And then it's going to be plus. And you can see that the area of like this front face here would just be h times x. And then there's 4 of those. Those would all be the same, right? So this one all the way around. So I can say plus 4hx. All right, so now, what am I after? Well, what we've been doing is, like when we maximize or minimize, we're trying to find, you know, when you sketch this thing out, if it, let's say it does this, right? We're trying to find where the derivative is 0. So we want to take the derivative and then set it to 0. You might see the problem here. How do I take the derivative when I have it in terms of x and h? So that's where we're going to use a second equation. This is like really like a systems of equations type of a thing, right? So to do that, we're going to make another equation that relates to the volume of the box because we have some information there. So let's do that. So the volume of this box is equal to base times height divided by 2. So this would just be x squared times h. Okay, so now how does that help us? Well, I know the volume, so I can put that in. So we've got 2,916 is equal to x squared times h. And now at this point, I could either solve for h, right? I could figure out h in terms of x or x in terms of h. And let's just look over here and see which one would probably be easier, right? Well, it's probably going to be easier if I can just turn this h into something in terms of x, right? Because then I've got all x's. That's going to be easier than changing both of these x's into, h's, right? Okay, so what's left to do? So we'll just divide both sides by x squared. So we get the equation 2,916 over x squared is equal to h. So this is where we're going to substitute in, instead of h, we're going to substitute in what we just found there. So a is equal to x squared plus 4 times, and then this is where we're going to put in 2,916 over x squared, and then times x. Okay, so you can see what happens here. We have x squared in the denominator and x in the numerator, so I'm going to cancel those. So we just have x in the denominator there now. And then simplifying this up a bit, so we get area is equal to x squared plus, and then 4 times that is 11,664 over x. And then I'm just going to write one more time. So a is equal to x squared plus 11,006. Come on, Ben. 664, and I'm going to write this as x to the power of -1, just so I can take the derivative easily. So now we're ready. Let's take the derivative. So the derivative of the area function would be 2x minus, and then 1,664. And then this would be x to the -2. So you know what? I might actually just write it though as x squared right now. That'd be the same thing, right? Just skipping that step. All right, so now that we have that, we're going to set this equal to 0, right? We want to maximize this. So 0 is equal to, because that's where the derivative is 0, right? That's where the slope is flat. So 0 is equal to 2x minus this. All right, so now I just need to get rid of the x or the variable in the denominator. So what I'm going to do here is I'm going to multiply every term by x squared. So x squared, and x squared. So 0 times x squared is still 0. And this becomes 2x cubed. And then those canceled. So minus 11,664. So a little bit of algebra here, just which I'm sure you guys can do at this point. We'd get 5,832 is equal to x cubed, and then you would take the cube root. So the cube root so we get a value for x of 18. Okay, so now that we have that value of x, right? So this should be 18 by 18. And then we can just throw this into our equation, right? So we've already rearranged something for h, so let's just use that. So we'll say h would just be 2,916 divided by 18 squared. So the height would be 9.